Hey guys, today we're going to look at the definition of a derivative. In order for us to do so, we need to be familiar with some vocabulary and some particular formulas. First, we're going to look at a secant line. The red line here, you see how it goes through two dots. That's called a secant line. A secant line that goes through a function is one it's a line that goes through exactly 2 points of the function. Now, if on this line I have 2 points, so on this first one, I have x and f of x, which we know is to be the y value. If I travel some distance, which we're going to call h, then we have these 2 points. We have x plus h, which is our original x plus the distance, and then we would have the y value when we have x plus h, so f of x plus h. If I were to look at this particular equation, we have f of x plus h minus f of x over x plus h minus x. If we look at this as x1, y1, and this as x2, y2, if I were to replace that in this formula, this is like saying y2 minus y1 over x2 minus x1. This would be familiar as slope. So that particular equation represents the slope of the secant line. Now, as h, which is the distance between the x values, approaches 0, what happens to the secant line? Well, if you look at the blue, these two lines, this line and the two dots are getting closer together, meaning that h value is decreasing. If I continue to decrease h, and as h is approaching 0, we end up with what's called a tangent line, which is a line that passes through exactly 1 point on your function. So as h approaches 0, the secant line becomes the tangent line. Now it's important to note, if you look at the secant line and the tangent line, their slopes are pretty much parallel. So if they're parallel, if the lines are parallel, that means that the slopes are equal. So if I look at this particular limit statement, I have the limit as h is approaching 0, so we're talking about the tangent line here, f of x plus h minus f of x all over h. What happened was that in the denominator we had x plus h minus x, so those x's canceled. So what this equation represents is the slope of the tangent line. That is the derivative. The derivative represents the slope of your tangent line. So let's look at how we would actually apply this. Now, this limit, the limit as h approaches 0, f of x plus h minus f of x all over h, all of that represents the slope of your tangent line. So if we're trying to find that limit, what I'm looking for is the slope of the tangent line for this particular function. When we actually find this limit, a lot of the times your answer is not necessarily a number, but an actual equation. And I'll explain that once we get this slope. So we're going to go ahead and find this limit. So we have the limit as h is approaching 0. We're going to do f of x plus h, meaning that I'm going to replace every x with x plus h. So negative x plus h squared minus 4 times x plus h plus 1. That's f of x plus h. Now I'm going to subtract all of f of x. So I'm going to open a parentheses so I remember that I need to distribute that negative. And all of this is over h. Now from here, you need to just work it out. We need to distribute that x plus h squared. We need to distribute the negative 4. We need to combine like terms. So at this point, what we're doing is just a lot of algebra. So we have the limit as h is approaching 0 of negative. Now x plus h squared. I'm going to kind of skip a little bit so that, to condense this video. But if you were to distribute that, remember that x plus h is this. I'm going to do it over here and then I'm going to erase it. x plus h times x plus h. When you FOIL, you get x squared plus xh. Then you have another xh, and then finally plus h squared. So what this would give me would be x squared plus 2xh plus h squared. So that's what I'm going to replace the x plus h squared with, is x squared plus 2xh plus h squared. So I'm just going to go ahead and erase that so I have that space there that we need. Okay. So now I'm going to go ahead and distribute that -4. We have negative, ooh, why did it change colors? Let's change that back. Okay. We have negative 4x minus 4h plus 1. Then I'm going to distribute this negative, so it'll be plus x squared plus 4x minus 1. And again, everything is all over h. At this point, I can see that I could cancel out the 4x's and I can cancel out the 1. So let's move on. We're going to continue with our algebra here. We have the limit as h is approaching 0. Now I'm going to distribute the negative at the beginning. So negative x squared minus 2xh minus h squared minus 4h plus x squared. And again, everything is over h. The x squareds cancel. And at this point, all you have left in the numerator is negative 2xh minus h squared minus 4h. Now, the whole point of these limits is that at some point you need to cancel out this h. Because if I were to just use the substitution method and plug in 0, I would get 0 in the denominator. So we need to find a way at some point to get rid of that h from the denominator. So what I can do now is I can factor out an h from the numerator so it can cancel from the denominator. So if I factor in h, I get negative 2x minus h minus 4 all over h. And see, the h's cancel. At this point, my limit is just the limit as h is approaching 0 of negative 2x minus h minus 4. And if I plug in h is equal to 0, basically this h goes away and I get negative 2x minus 4. This is my derivative for this particular function. So since our function is f of x, the derivative is f prime of x. It looks like a little apostrophe, and that stands for prime. So that is our first derivative, which is negative 2x minus 4. Now the reason why my derivative is an actual equation is because if I were to go along this parabola here, and it depends on the point that I land on, like let's say I want to find the slope of the tangent line at negative 4. If I plug in negative 4 into my f prime, I would get negative 2 times negative 4, which is a positive 8, minus 4 is 4. And when I come here to x is equal to negative 4, let me just erase this here so we can see it. Right here. I can see that my slope here for the tangent line, whoa, I completely missed. Let's try that again. Oh my God, I can't. You get what I'm saying. We see that the line would be a positive tangent line, meaning it has to have a positive slope. If I plug in negative 2 is over here. My tangent line here is horizontal. So that means I can expect that my derivative would equal to 0, which is the slope of that particular line. So f prime of negative 2, if I plug it in, I get negative 2 times negative 2, which is a positive 4, minus 4, which is 0. And finally, if I plug in negative 1 is over here. If I were to draw that tangent line you can see that it is decreasing. So this would be a negative slope. And when I plug in -1, I will get -2 times -1, which is a +2, minus 4 is -2. And so I get that negative slope. So again, all of this checks out. So the derivative, which we find by finding that limit, gives us the slope of the tangent line and gives us the equation that we can use to find the slope of the tangent line at any point of our function. So this is really important. F prime of x, which is the derivative, is equal to this particular limit. This is called the definition of the derivative. And that particular limit is called the difference quotient. It's called the difference quotient because, as you can see in the numerator, is a difference. And since it is a fraction, it is division, so it is a quotient. So when you see a derivative, you need to think, okay, I'm finding the slope of the tangent line. And when you see find the slope of the tangent line, you need to think, I have to find the derivative. So they're the same exact thing. So let's just practice with a couple questions. So we're going to find the limit as h is approaching 0 of f of x plus h. So that's 3 times x plus h minus 2 minus all of f of x, which is 3x minus 2, all over h. Now we can just distribute the 3, and that would give me 3x plus 3h minus 2 minus 3x plus 2, all over h. My 3x's here would cancel, the 2's would cancel, and I'm left with the limit as h is approaching 0 of 3h over h. The h's now cancel, and my final limit is the limit as h is approaching 0 for 3. Remember that the limit as h is approaching anything of any constant is always going to equal to the constant. So my f prime of x, the derivative of that particular linear equation, is equal to 3. Now this one does equal to a number, and that's because the function is linear, meaning that if you were to draw a tangent line anywhere on that line, the slope is always going to equal to 3, no matter where you go on the line. And this makes sense, right? Because a line doesn't curve, it doesn't change direction, so no matter what, the slope is always the same on that line. Now let's try with this particular function. We have the limit as h is approaching 0. Remember f of x plus h first, so 4 times x plus h, close parentheses, squared, plus 1. Then minus all of f of x, which is 4x squared plus 1, and everything is all over h. So now we are going to need to distribute. So we have 4 x plus h squared. Remember, that's x plus h times x plus h, which is x squared plus 2xh plus h squared plus 1. I'm going to distribute the negative, which is negative 4x squared minus 1. These ones would cancel. Everything is all over h. Now we can go ahead and distribute the 4. So we have the limit as h is approaching 0 of 4x squared plus 8xh plus 4h squared minus 4x squared all over h. And again, these x squareds cancel. I can see in the numerator all that's left is 8xh plus 4h squared. So at this point, I can go ahead and factor that h. So h times 8x plus 4h all over h. The h's cancel. And my final limit, the limit as h is approaching 0 of 8x plus 4h. If I plug in h is equal to 0, my derivative is equal to xh. So f prime of x is equal to 8x. Now, throughout the year, we're going to be finding the equation of the tangent line. So we've learned how to find the slope, but now we need to get the entire equation. And so I put some steps for us here to follow. In order for us to find the equation of a line, right, or any line, we need two things. We need a point and we need a slope. And if we have the point and we have the slope, then we can plug it in to point-slope form. Now, the good thing about AP Calculus is that when you take the AP exam, they're testing you on your calculus, not so much on your algebra, although you do need to do some complex algebra as you're working. But once you have your point and your slope, if you just leave your line in point-slope form, that is good. You just leave it like that. You don't have to write it out as y equals mx plus b in slope-intercept form. So in order for us to get it into this form, we need that point of tangency, meaning where the tangent line touches your function. And we do that by taking the x value that is given to us and plugging it into the function. So my point of tangency, that's the first thing that we're going to find. Which we find that by plugging in x is equal to 2 into our function. So f of 2 is negative 3 times 2 squared plus 4. When we work this out, 2 squared is 4 times negative 3 is negative 12, and negative 12 plus 4 is equal to negative 8. So my point here is 2, negative 8. This is x1 and this is y1. So that part is complete. The next part is to find, so just so we can follow the rules, right? We found f of x. We stated that this is our point of tangency. Now we're going to find f prime of x, which is that limit that we were discussing. So the limit as h is approaching 0 of f of x, which is f of x plus h, negative 3x plus h squared plus 4 minus all of f of x, which is negative 3x squared plus 4, and it's all over h. Sometimes I write it like this in order to save on some space. Now it's time to do our distributing. So the limit as h is approaching 0 of negative 3, x plus h squared is x squared plus 2xh plus h squared plus 4 plus 3x squared minus 4, and everything is all over h. The 4's cancel, and now I can distribute that negative 3, which will give us negative 3x squared minus 6xh minus 3h squared plus 3x squared, and again everything is all over h. I can cancel these 3x squareds. If I rewrite my limit, I can see that I have only h's left in the numerator, so I can factor out that h. So we have h times negative 6x minus 3h, and everything is over h. My h's cancel, and so I have the limit as h is approaching 0 of negative 6x minus 3h, which when you plug in h is equal to 0, we end up with negative 6x. So what does that mean? That means that my derivative, f prime of x, is equal to negative 6x. But I need the slope of the tangent line when x is equal to 2. So what we're looking for is f prime of 2, which when I just plug it in, I would get negative 6 times 2, which is negative 12. So now I have the slope of the tangent line. I also have the point of the tangent line. So now I can write my final equation, which would be y minus y1, which is negative 8, so plus 8, is equal to negative 12, my slope, times x minus x1, which is 2. And this would be my final answer. All right, so now we're going to just, we're going to be practicing with the slope of the tangent line and finding the equation of the tangent line very frequently throughout the year. But for now, what I want us to do is I just want us to apply that limit again for this particular function, the square root of x plus 2. And we're going to find the derivative when x is equal to 7. And we're going to find this derivative in two different ways. We're going to use the way that we just learned, the limit, using the limit of the difference quotient. And then we're going to use this particular limit to find that derivative as well. And we're going to compare. So first, for this one, we have the limit as h is approaching 0 of the square root of x plus h plus 2. Remember, it's always x plus h first, minus f of x, which is the square root of x plus 2, all over h. Remember that when we have a radical, and there's nothing else that I can do, I can't just substitute, because if h is equal to 0, I'd have 0 in the denominator. You would have to multiply by the conjugate, which is the square root of x plus h plus 2 plus the square root of x plus 2. And we have to do that to both the numerator and the denominator. Now, when you're multiplying conjugates, remember that those middle terms always cancel out. So I can just multiply the first with the first and the last with the last if you want to take a little shortcut. So the limit as h is approaching 0. What we would end up here in the numerator would be x plus h plus 2, since the square roots would cancel, minus, when you multiply the square roots of x plus 2, those square roots would cancel, so x plus 2, all over h, times the square root of x plus h plus 2, plus the square root of x plus 2. If I distribute this negative, we would get x plus h plus 2 minus x minus 2 all over h times the square root of x plus h plus 2 plus the square root of x plus 2. In the numerator, I can see that the x's cancel and the 2's also cancel. And so all that's left in the numerator is this h. But I can cancel that h with the h in the denominator. So since there's nothing left in the numerator, that's a 1. So the limit as h is approaching 0, we would have 1 all over the square root of x plus h plus 2 plus the square root of x plus 2. Now I can plug in h is equal to 0. And that would leave me with 1 over the square root of x plus 2 plus the square root of x plus 2, which bottom line, f prime of x would equal to 1 over 2 times the square root of x plus 2. I am now ready to plug in x is equal to 7 since I have the derivative. So f prime of 7 is going to equal to 1 over 2, and then the square root of 7 plus 2 is the square root of 9, which is 3. So 1 over 2 times 3 leaves me with my final answer of 1 over 6. Okay, so now that I found the limit this way, let's find the limit, the derivative. Let's find this particular limit, which is the limit as x is approaching a. A is whatever x value is given to you in the question. So we're using the same function, we're using the same x values, so a is equal to 7. Okay, and then we're going to plug in f of x minus f of a. F of a we would find by plugging in the 7 into the actual function, which is the square root of 7 plus 2, which is the square root of 9, which is equal to 3. So now I'm ready to find this particular limit. So we have the limit as x is approaching 7 of f of x, which is the square root of x plus 2, minus f of a, which is 3, all over x minus 7. Now, in order to find this limit, we need to use the conjugate method again. So I'm going to multiply by the square root of x plus 2 plus 3. Remember, conjugates, the middle terms always cancel, so we can just multiply first with the first, last with the last, and it would give me the limit as x is approaching 7 of x plus 2, because the square roots would cancel, and negative 3 times 3 is a negative 9, all over x minus 7 times the square root of x plus 2 plus 3. In the numerator, if you simplify this, x plus 2 minus 9 is x minus 7, all over x minus 7 times the square root of x plus 2 plus 3. These x minus 7's cancel out. So your final limit as x is approaching 7 of 1 over the square root of x plus 2 plus 3 is equal to 1 over. Now 7 plus 2 is 9, the square root of 9 is 3, plus 3, which is equal to 1 over 6. And we can see that we end up with the same answer as we did here. This is called the alternate definition of the derivative. So this gives us the derivative value at a particular x value. So f prime of 7 is equal to 1 over 6. So to kind of put this all together, the definition of the derivative is that limit of the difference quotient. This limit gives you the general equation for the derivative, and we can use it to plug in any x value to find the slope of the tangent line at that x. So it allows us to find the derivative at any point. Versus the limit that we just found, the alternate form of the definition of the derivative, gives us the slope of the tangent line at a particular x value, which is the x value that whatever a is equal to, whatever x is approaching. Okay, so now we're going to put everything all together. We're going to find the equation of the tangent line using the difference quotient at the indicated value of x for the given function. So here we go. Remember, if we're finding the equation of the tangent line, I also need the point of tangency. And that is by finding f of negative 1. When I plug in negative 1, I get 3 times negative 1 squared, which is a positive 1, so 3. Then plus 3 times negative 1 will be minus 3, plus 3. So that means that f of negative 1 is equal to 3. So this is my point of tangency, the negative 1 comma 3. Okay, so now we need to find the limit, which is going to be our derivative. So the limit as h is approaching 0. First, we're going to do f of x plus h, so 3 times x plus h squared, plus 3 times x plus h plus 3, minus all of f of x, which is 3x squared plus 3x plus 3, and everything is going to be over h. Now we have to distribute and do all that algebra. So the limit as h is approaching 0, we have the 3 times x squared plus 2xh plus h squared. I'm going to distribute the 3, so plus 3x plus 3h plus 3 minus 3x squared minus 3x minus 3, and everything is all over h. I can already start canceling some things out. I can cancel out the 3x's. I can also cancel out the 3. So now I'm going to distribute this last 3, and I get the limit as h is approaching 0 of 3x squared plus 6xh plus 3h squared plus 3h minus 3x squared, and everything is over h. The 3x squareds cancel. And I can see in the numerator, now I only have terms left with h. So I can factor out that h. So h times 6x plus 3h plus 3. And everything is over h. The h's cancel. And my final limit is h is approaching 0, is 6x plus 3h plus 3. And if I plug in h is equal to 0, I end up with the equation 6x plus 3. So what does that mean? That means that f prime of x is equal to 6x plus 3. So this will give me my slope of the tangent line. But what I need is the slope of the tangent line when x is equal to -1. So if I plug in -1, I get 6 times -1 plus 3, which is equal to -3. So now that I have my slope, I have the point, I am ready to write the equation of the tangent line. And my equation would be y minus the y value, which is 3, is equal to the slope, so -3, times x, and then minus -1 will be plus 1. And this would be the slope of my tangent line. And that's the introduction to derivative and how to find the equations of your tangent lines.